Okay, this is going to be the 2sample classwork that we go through. You know, honestly, I think this is where some of it will start to click. If you find that it's starting to click after the first two problems, I would pause the video, try to work the third and fourth problems on your own, and then watch the video from that point on and see how you did. All right, so let's talk a little bit about this data that I'm giving you. This data was collected on 3 to 5-year-olds on several gross motor skills before and after a dance intervention. The PMA is a test. I'm not sure why that says text. Probably autocorrect. The PMA is a test that measures 12 gross motor skills according to Nevada state standards. The sum score is summed across the 12 skills such that 12 denotes a perfect score. Children either received a 0, did not meet the standard, or 1 met the standard. Balance is a continuous variable measured up to a maximum of 30 seconds. Boxing is a dichotomous variable of either 0 did not meet standard or 1 met standard. And the number of hops is a continuous variable that counted the number of hops during a set time. For demographics, we have biological sex, where 1 is male, 2 is female, and ethnicity, where 1 is non-Hispanic and 2 is Hispanic. All right, so for all problems, I'm going to walk you through it. We're going to determine if we have dependent or independent samples. If we have independent samples, we need to make a determination about our variances. We're going to write our hypotheses, state whether we're running a student or Welsh test, find the p-value, state the decision, and draw the conclusion. If the difference is significant, we're going to interpret the effect size, all right? And we're just going to use an alpha of 5% all the way through this. All right, so question 1, determine if boys and girls differ on the pre-intervention number of hops. All right, so we're doing a comparison between sex here, boys and girls. So this is going to be independent. All right, and for we're just testing if boys and girls differ on the number of hops. So we're going to have mu boys equal to mu girls, oops, and then mu boys, and I need my not equal. All right, not equal to mu girls. Okay. All right, so now let's go over into JASP. All right, and we are going to go into t-test independent. All right, we are interested in pre-intervention hops, so that is just the plain old hops here, because notice the post says post. So we've got hops, and our grouping variable is sex. All right, and let's just talk a little bit. So we want to do, let's check our variances first. So we'll do our Levine test here, and notice we have a p-value greater than 5%, so we can assume variances are equal. All right. And so since we are assuming variances are equal, that means we are going to run the student test. All right, and we only have not equal to in our alternative. We're just testing a difference. All right, and so let's check our effect size. All right, so we've got, let's just start going through all of our results here. Okay. So we are testing boys and girls on the pre-intervention hops. The test for equality of variances said we can assume equal. So I checked student. I checked not equal to, because that's what my alternative says. And I checked effect size in the event that I have a significant result. Okay? All right, so now let's start going through the numbers in this box. All right, our p-value right here is 0.014, all right, which is less than 5%. So our decision is to reject the null. And our conclusion is there is enough evidence to conclude, there's enough evidence to conclude boys and girls significantly differ on the number of hops pre-intervention. All right, and our effect size here is 0.115. All right, and remember, we're not really concerned about positive or negative. The fact it's negative and the fact that females are the 2 just means that being female means you have a lower number of hops on average. And our effect size here is between very small and small, because remember, small starts at 0.2. All right, so we're somewhere between a very small and small effect size, so really not that much. All right, let's look at the second question. Determine if children complete more hops after the intervention. All right, so now we're testing hops before and after. So this is a pre-post comparison. So that means for each child, we are putting in their pre-hop score and their post-hop score. So this would be dependent. All right, and so we're going to have, so we want to know in our dependent here, I'm going to say let's do post minus pre. That's typically how you want to do when you're testing post and pre. You typically want to put your post in first. All right, so we are going to test here we want to test if there's more after the intervention. So our mu difference here would be greater than 0, right? So if post is bigger than pre, then that difference would be greater than 0. And then our null then would be mu d, and we need to insert a less than or equal to. All right, there's our less than or equal to 0. All right, and all right, so now we want to go into paired. All right, and you'll see that when we put in our variables, well, here I'll show you. Here's a hops. You put them in side by side, and so again, we want to test post minus pre. So let's put in our post hops first, then our pre hops. All right, this is going to be a student. We are testing that the post is greater, so measure 1 is greater than measure 2. All right, and let's get the effect size in case it is significant. All right, so now let's interpret these results down here. All right, variance equality does not apply for paired T. The type of test is student. All right, as you can see, that's Wilcoxon-signed rake is something that we will see with non-parametric. We'll worry about that in a few weeks. All right, our p-value, according to our box down here, is less than 0.001. So our decision is to reject the null. And the conclusion, there is a children on average complete significantly more hops after the intervention. All right, but what's the effect size? All right, we see our effect size is 0.408. So this is a small to medium effect. Remember, medium is considered 0.5, so we're getting up close to a medium effect size. All right, so moving forward, determine if non-Hispanics and Hispanics differ on the post-intervention boxing skill. All right, so now we are comparing two ethnicities. So this would be independent. All right, and we'll have mu non-Hispanic all right, equal to mu Hispanic and mu non-Hispanic, and I'm going to go up here and copy my not equal to mu Hispanic. All right, so we want to go over here. So now we've got to go back to independent, and we're looking at post-intervention boxing. So post-boxing, and we're interested in comparing Hispanics and non-Hispanics. All right, let's look at variances first. All right, and we notice here we've got a significant p-value on our variance test. So this means that our variances are unequal. That means our type of test is a Welch test. All right, so I need to check Welch. I am only testing an equal to, not equal to difference, and I'm going to go ahead and get the effect size in case it is significant. All right, so what can we interpret here? Well, our p-value for the Welch test is less than 0.001. That means we reject the null. All right, we can conclude that non-Hispanics and Hispanics significantly differ on the post-intervention boxing skill. All right, but what is the, let me fix we here. What is the effect size? We see our effect size is 0.172. This is right at 0.2, so I would probably call this a small effect. Okay. All right, last one. Determine if children's balance time changes from the intervention. All right, so now we're going to be comparing pre-balance and post-balance. All right, so does balance get better? All right, so this is going to be dependent. All right, because each child has a measure, right, of pre and post. So we are just going to be testing if there is a difference. All right, so if the mean difference is equal to or not equal to 0, variance does not matter since this is a dependent test. All right. So let's go into paired T. All right, and we are interested in balance, so we're going to put in our post first, post, pre. All right, we've got student, we've got equal to, not equal to for our hypothesis, and again, let's do effect size in case it is significant. So our test here is student. Our p-value is less than 0.001. Our decision is to reject the null. All right, so children's balance time significantly differs from the intervention. All right, and our effect size is 0.09, so very small effect. All right, and that's interesting, right? That's a negative. Let's talk about this for a second. This is a negative Cohen's d. All right, so that means that actually pre-balance had a higher mean than post-balance, that the balancing got worse with the intervention, and that is something we definitely do not want to see. So really, 99 times out of 100, we want to test if something improved in the direction we're expecting it to from our intervention, right? So here, we're expecting the balance time to increase. So really what we would want to test here is that the post is greater, right? And when we test that, we see we get a very non-significant p-value, a p-value of 1. So really what we're concluding here is that balance did not significantly improve from the intervention. In fact, it actually worsened. All right, so there's some classwork problems for you. You might even want to go through this again before you attempt the homework. But by the time you finish the homework, you should be good and ready for the quiz.